What is a feature definition? A feature definition describes the engineering properties and sets the symbology for a feature. The engineering properties allow it to model the real-world thing which is being represented, and then the symbology settings allow it to be displayed properly in various contexts. So let's see how this works. In our previous video we looked at this edge of pavement, and we talked about how the feature was represented in different contexts. It's the feature definition that allows it to know that. So you see, if I look at the information for this edge of pavement, you'll see it has a feature definition and a name. It's this feature definition that describes how this edge of pavement behaves. So let's take a look at that EOP feature definition. So if we look in Project Explorer in the Civil Standards, then we can see here is the feature definition. I'll look at the properties of this. This is the EOP, which is assigned to that edge of pavement feature. And so the engineering properties that we talked about are these, and so some naming prefixes that are provided, and some settings for how this feature can be used in the design. And in some other sessions, someone will talk about how these settings are used. But notice, for example, one of the properties is how does this thing behave in a terrain model. That's set to brake line. There are also properties for how does this behave in a survey context, and we'll look at those in a later session. Then it also describes the symbology. And so in the plan, how do we describe the symbology in a plan context? Remember, this edge of pavement in plan is represented by a solid black line. How does it know that? Well, we set it here to link to a native style, which in this case is Geopack, and we'll look at how these native styles work in a moment. There's another setting for profile. How does it look in profile? You'll notice that it's set to the same thing. And then we'll remember that in 3D, and just to remind us, in plan it's a solid black line. In 3D, remember, over here it's a solid gray line. And the reason it's able to do that is we've used a different setting for 3D. So our plan setting used this. Our 3D setting used a different symbology. That's the reason. That's the way we're able to control how this feature looks in the various contexts. So let's take a peek then at how we define the symbology, and we'll look at the 3D first, because this is this use of a template style is the same for all three products, Geopack, En-ROADS, and MX. You'll notice that it's linked to a MicroStation template, which I've named Muted 3D. There's no magic in that name, I just created it that way. So let's open up element information, or not element templates. These are configured in the DGN file. And so here's the Muted 3D. And so what I've told it is for an edge of pavement in 3D, use this setting called Muted 3D, which, as you see, is a solid gray line. And that's how we get this solid gray line. Now let's go back then. So we used an element template to get the 3D to solid gray line. But in plan and profile, we used a native style. And so let's look at the plan. You'll notice they're both set the same. This is where the three products begin to diverge. And it's because the native products, Geopack, Inroads, and MX, have different formats for what they use for styles, or in the Select Series 3 world, what we call feature definitions. So in this case, I'm running Power Geopack. We'll look at Inroads and MX in a moment. So it's using a native style called EP Proposed. So I'll open up Geopack's Design and Computation Manager, and I'll drill down and find that setting, EP Proposed, and let's review what's there. So in the feature definition, we say use native style EP Proposed. In Geopack, that comes from the DDB file, and so this links to that. And you'll notice that that is the solid black line, and we use this setting for both plan and profile. So that's how the Geopack works. Now we're looking at the same project except in Power Inroads. Notice I'm running Power Inroads now. You may notice that the structure of the feature definitions is a little different. We'll talk about that in a later session. So here is our Edge of Pavement feature definition. All these things will look very much the same, but let's take a look here. Again, plan and profile are pointed to a native style, but in this case it's an Inroads native style. And so if I open the Inroads Style Manager, here is the EOP. Alright, so if we take a look then, the Edge of Pavement feature definition for plan and profile uses an XIN style to determine the symbology. And in this case, then the symbology is proposed asphalt, which is a solid black line. So very similar to Geopack, but just a slight variation of pointing to the XIN file, which is Inroads style file, and in Geopack we used the DDB file.
Okay, so let's take a look at this in the MX environment now. So what we have here is just some simplistic features bringing in from the MX Road PSS. And I'm dealing here with the carriageways and shoulders. So looking in the left-hand view, what we can see we have are the shoulder feature. We have a name being applied here. Now this is coming from the feature name, so this is just a text name that we can type in. The feature definition is the link back to the native product here. And so this is the feature definition we're defining and that we're used to using inside of MX. Similarly, if I have a look at the yellow feature, what we have there, REP, so right edge of pavement, carriageway edge. And similarly on the left hand side, same type of thing, just do it from the quick tooltip, so LEP, carriageway, and then the shoulder as well. So let's have a look at that in the PSS file. So in the PSS file, MX has a flat structure, so all of the features are listed just as a flat structure running down through them. That's how they're listed in our typical dialogues. So if we take a look at shoulder's edge, it has one style definition for the plan style set. that is drawing on a level name of shoulders and defining the level properties or assuming them from a DGN library. So how does this work when we link it through for a shoulder's edge and have a look at the properties? Well, as we've seen, for a feature there are various use cases for it. So we have the plan representation and the native style. So what we're doing here is we're picking the native style from the MX PSS. We're looking at the standard MX features there. Similarly, by default, when we import, we set the native style as the same for the various modes that we can view it in, be it projected profile and profile. What I've done at the bottom here for the 3D mode, though, is actually define a non-native style. So I've set the native style to be none, which is normally set as shoulder's edge, and then I've referenced this into an element template, shoulder outside edge. So this is allowing us to give the essentially an override of multiple definitions on the style from a single PSS. So if I go into this and have a look at shoulders outside edge, I've defined it here on a different level called shoulders. It's grey in colour and continuous, and the pavement outside edge I've drawn with a dotted line. And this is as we see here. So the same feature is used, but we have different view modes available to it when we link through from a PSS file. So it enriches the basic flat structure and provides multiple use cases.